Alright, so oxygen needs 6 electron dots. Alright, from that electron dot formula. Oxygen is in the second row of the periodic table, which we call the second period, which means the position of oxygen in this row indicates the addition of electrons to the second primary energy level. The placement of oxygen over here means that we're also putting electrons into the what sublevel region? D. Okay, and that's a double balloon-shaped orbital. Okay, so we've got to put some electrons in the first primary level, which only has an s orbital first, then some electrons in the second primary level. This would be the s sublevel, so 2s, we put some electrons there, and then 1, 2, 3, 4 electrons in 2d. Correct? So we have in the valence level then 2 s orbital electrons and 4 p orbital electrons, so a total of 6 valence electrons. Got that? Alright, so we need 1, 2, 3, 4, and then pair them up somewhere. 5, 6. Okay? Now, if I'm going to bond that with hydrogen to make water, I need to know how many dots to put around a hydrogen. Yes? What's what? There's a lot of stuff over there. I mean, the golf ball's floating? We'll get to that. Okay? How many electron dots do I put around a hydrogen? 1. Let's stick with what we're doing right here, okay? So I need 2 hydrogens, each with a dot. Okay? Looking at the electron dot formulas for oxygen and hydrogen, what should I plan to share? Which one? The single ones on oxygen with the one on the hydrogen. That's a good way to describe it. Okay? Is that the only one? Are we done? We've got to do the other one too. Okay, good. And so we had an electron dot formula that's now, because we've shown the sharing, it's called the sharing arrangement. Well, actually, we had 3 electron dot formulas. 1 electron dot formula for oxygen, 1 for two of them, 1 for each hydrogen. And then we put them together through this circling of electrons to show what sharing, we get a sharing arrangement. Then from that, then we can squeeze those electrons in between those atoms. So hydrogen squeezes up here to the oxygen and sort of pushes those electrons one above and one below. And so we get them up like that. And when we take these two, one above and one below, and we squeeze it together, they pop out to the side. So we get them like this. And so the other 2 electrons, those are called lone pairs. The unpaired electrons, okay, unpaired electrons, lone, L-O-N-E, pairs. Okay? And the electrons that are shared are called shared pairs. Alright? That makes sense? Alright, so the oxygen itself then has an orbital rotation like this. Before it does any bonding, it has this orbital rotation. And we're going to change that to hybridize the valence level orbitals. This only happens with sharing of electrons, by the way. Okay, so we're going to hybridize so that we have 1s, and then we're going to have 4 orbitals that are forming sp3s. 1, 2, 3, 4. They're hybridizing into a new kind of set of orbitals. Same number of orbitals, but they're changing their shape and energy. So that's 2 in the second primary level, sp3. So sp3 is a type of orbital. 2 just tells you what the main primary energy level is. Okay, the valence level. And so we have 1, 2, 3, 4, 5, 6. We're going to do the same thing. 1 in each orbital and pair them up until we're done. Okay? Got that?
Yeah.
All right. Now, what that means is I've got 4 new kinds of orbitals, right? Got one that goes like this, and one that goes like this, and one that comes out toward you, and then one that goes back behind everything, sort of, kind of. And those are then going to, the ones that have just one electron in them, like these two orbitals here, are going to overlap with a hydrogen to get two electrons to share them in the same orbital. And these are going to be lone pairs over here with nothing, basically, no bonding, but they have the electrons sitting in there. All right? You got all that? What? I have no idea what that is. Oh, but she's not a pair. She's one person. Okay. All right. Of course, she's, double special. Maybe that's the reason she's a lone pair. I don't know. All right. Well, you did make an analogy, sort of, okay? But it's like, when you go out on a date, and you double date, all right? If you're by yourself, that's a lone pair. If it's just you and your date, that's a lone pair. Okay, when you're with other people, you're not a lone pair anymore. Well, I don't care about that. I'm just trying to stretch the analogy a little bit to make it a little more realistic. Gracious. All right. Now, the shape of this is actually tetrahedral. So we actually have a hydrogen sitting up here, a hydrogen coming out here, and we have some electrons out here, which I'm going to show these as the electron dots. Okay, so that's the actual shape of the molecule using the electron dots here. Got that? Because it's this shape right here, isn't it? All right, but that's the shape of the molecule showing the electron dots. The actual shape of the molecule doesn't show the lone pairs. Okay? The actual shape of the molecule doesn't show the lone pairs. Even though they're there, even though they're taking up space and making the molecule kind of squish around a little bit, we don't show them. So this is the actual shape of the molecule. Because you, being a chemist now, know about the underlying theory about the existence of those lone pairs out here, which are taking up space. All right? We're tying all this together for you? Well, we're going to keep working on it until you get solid hope. All right? All right. Now, let's find a way to go from this to this and skip through all of that. We don't really need this here to get to there. All right? We're going to kind of go from just here. Actually, we're going to start here, go to here, and then get to this. I'm going to show you a technique for doing that that makes your life a little bit easier. Okay? So go from here to here. There's an intermediate step between here and here, and then finally end up here. Yes?
You just draw the oxygen and then the two lines with the hydrogen on the end of it, because it's the two that's there.
Could, but I'm going to show you an intermediate step that for some people, this might work for you perfectly, but I'm going to show you an intermediate step that's going to make it easier for a lot of people. Okay? So, we start with a sharing arrangement. This is the method we're going to use. And when we get to more complex molecules, it's going to make your life a lot easier anyway. So there's our electron dot formulas. Electron dot formula for hydrogen, another electron dot for this hydrogen, an electron dot formula for this oxygen. And then we're going to show the sharing arrangement like this. So now that becomes a sharing arrangement. Went from 3 electron dot formulas to a sharing arrangement. Huh? You have. From the sharing arrangement, you're going to go to the Lewis dot formula. Okay? Then from the Lewis dot formula, we're going to do what's called an electron pair shape. Okay? So we went from electron dot formula to sharing arrangement to Lewis dot formula. Okay? And now we're going to what's called the electron pair shape. Now, the way you do the electron pair shape is you find your central atom, the one that you're interested in finding out the shape of the bonds around. around which you're trying to find the shape of the bonds, the direction of the bonds. That's oxygen. And all you got to do is just count the sets, not pairs necessarily, because later on when we get to double and triple bonding, we'll find out about that. Count the sets of electrons around that central atom. That's 4. If you have 4 sets of electrons around the central atom, it will make a tetrahedral. If you have 4 sets of electrons around a central atom, it will form a tetrahedral. If you have 4 sets of electrons around a central atom, it will form a tetrahedral. Sets of electrons around a central atom, and I say central atom because at this level, at this point in time, they're always going to be in the center. But when we get to really complex molecules, you just kind of have to know you're looking at different atoms in the structure. Might be the one you're looking at the time. You've got to consider which one you're looking at the time. Around a central atom, the bonds will form a tetrahedral. Okay? So what we're going to do here is to draw the tetrahedral with our electron pairs on it. So we're going to have one going up. Now, really you could turn it in any direction you want to. Spin it around if you want to. Okay, right here I put one up and one to this side. So this time I'm going to put one up and one to this side, which means the double set of bonds over here has to go over here.
So do you have to draw that every time?
Yep.
To set the bonds or whatever?
Yep. All right. And so you're going to put the electrons on there. Okay. Just put the electrons on the end of the arms. Okay. We can call those arms. Okay. All right. So then this has a tetrahedral. Electron pair shape. Tetrahedral electron pair shape. Okay? The next step then, so that's the intermediate step. The next step then is to plug the shared atoms, the atoms that are sharing electrons, onto as many arms as necessary. Well, how many arms are we going to plug it onto? 2. Just 2 of them. And with a tetrahedral, you can plug it on any one of the 2 arms you want to. You can plug it on these 2 arms, or this one and this one, or this one and the one in the back, or these 2 right here. Okay? It's just easier to see the shape if you put it on these 2 right here. It's not necessary, but it's easier to see the shape when you do. So the next thing is we're going to redraw exactly the same drawing, but do it in pencil. Okay. I'm going to put my electron dots on there. So I'm redrawing the exact same drawing, but now I'm going to replace any 2 pairs of electrons I want to. I'm sharing 2 pairs of electrons right here, right? One with this hydrogen and one with this one. So I can pick any one of these arms, because I got 2 electrons on all the arms, and put hydrogen on 2 of those arms. Does that make sense?
Yeah.
So how about I put it on the top and the one to the left side here? The easy ones. Okay? And now we have something called a tetrahedral modified electron pair shape. Okay? So let's see, this was the sharing arrangement. That's what we're going to do in the next step. Okay, then we get a Lewis dot formula. Well, as we go along, it'll make it so that you get a more sure result. You're more likely to get the correct answer if you follow the procedure. Okay? Then from this, we're going to finish up. We're going to redraw exactly the same drawing again, So here's my oxygen in the middle. I got an arm coming up here, an arm coming down here, one coming out toward you away from the piece of paper, one going back behind like that. And for the final drawing then, all I have to do is erase the lone pairs. When I erase the lone pairs, I have the molecular shape. But this is not tetrahedral anymore. Tetrahedral needs 4 arms. This one doesn't have 4 arms. Only got 2, like you and me. Okay? So this is called, well, what would you call that? What would you call this shape?
Bihedral.
You could call it bihedral, I suppose. But you know what we call it? We've got this real technical word. Bent. It's a bent molecular shape. A bent molecular shape. And I'm just going to go back over it with a darker pen here to make it clear. Okay? M-O-L-E, like molecule with an R on the end. M-O-L-E-C-U-L-A-R. I'm sorry, my writing got a little sloppy there. Okay? Getting that? So this is the way for predicting the shape of a molecule. Okay? That's how we're going to do it. Got that? Let's try again. Oh, you want to take a little break, a breather, and stretch a minute? Get a drink of water or something? Yeah, I know we're going through a lot of stuff, and you're getting a headache from all this. So let's just take a short break.